Hey all, welcome back to another video. Today's first question is, the number 64 is both a perfect cube and a perfect square, since 4 to the power of 3 equals 64 and 8 to the power of 2 equals 64. What is the next larger number that is both a perfect cube and a perfect square? So one thing you guys can notice here is that since 4 to the power of 3 is basically equivalent to 2 to the power of 2 to the power of 3, and 8 to the power of 2 is basically equivalent to 2 to the power of 3 to the power of 2. If you guys know your exponents, you'll know that these two equations are equal. So what does that get us then? Why am I telling you guys this? Because you guys can notice sort of a pattern here. The perfect square and the perfect cube are both equivalent to 2 to the power of 6. So let's think about that. If 3 is the cube and 2 is the square, then that means that number, say like x, is both a square and a cube in either way you want. So that's like the base number, like 2 is the base number here. So then what would x be in our equation here? So now we know that it has to be to the power of 6. But what number would it be? Since 2 was the one before, we're going to try 3. Since it's the next larger one, so we're going 3 to the power of 6, which is basically 3 to the power of 3 to the power of 2, which is also equal to 27 times 27. So 7 times 7 is 49. 7 times 2, 14, 18. 14 again, and 2 times 2, 4, 5. 9, 12, 7. So the answer to this problem is 7, 2, 9. I have gotten myself one of those like old school color palettes because I really like the idea of like writing on like a whiteboard. Anyway, moving on to problem number 2. Suppose that a and b are positive integers with a being greater than b, and with LCM AB equaling 462 and GCD AB equals 33. Find the largest prime factor of a that is not a prime factor of b. So basically, if we're going to take apart 462 here, which we are, you're going to find that if the GCD is 33, that means that both a and b, if we prime factorize both of them, are going to have 3 and 11 in it. So technically speaking, if we prime factorize 462, we'll also probably find 3 and 11. So let's take this apart here. We can obviously go 2 first, and then you would get 2, 3, 1. Then we kick this down a little bit. You can go by 3s. The first one you'd go 7, 77, and you'd get 7, 11. So like we predicted, here is a 3, and there's an 11. And we know that both a and b have 3 and 11. So that can be part of our equation now. So 3 times 11 times like x, and then b being 3 times 11 times y. So we're looking for the other two numbers here that are not contained in 33, which just so happen to be in the situation 2 and 7. And how do we know which a and b, which one has the 2 and which one has the 7? Well, a is greater than b, and both of them have 33 as their base number. So obviously, a is going to have 7, and b is going to have 2. So what prime factor does a have? Since this is all prime factorized down, that is not a prime factor of b, it's 7. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new. And I'll see you guys on the next one. Bye!